Hey, good afternoon, everyone. My name is Rachel, and I'm the Research Engagement Strategist with UBC ARC. Welcome to today's session on Introduction to Bash Command Line Interface. We're really glad that you're here. Before we get started, I'd like to go over a few quick housekeeping items. The session is being recorded, and the recording will be uploaded to our UBC ARC YouTube channel after the event. The slide deck will also be shared with you afterwards, so no need to worry about taking notes unless you like to. All the links on the slides are clickable, so feel free to follow along as the instructor goes through them. Since we have a fairly small group today, feel free to ask questions at any time. You can type it into the chat, use the Q&A feature, or unmute yourself to ask a question. If you have any issues unmuting, just let me know and I'll help out. With that, I'm pleased to introduce today's instructor, Jacob Lachey. Jacob is a senior systems analyst with UBC ARC. He holds a PhD in physics from the South Dakota School of Mines and Technology. His research background is in quantum computing, photonics, and computational modeling. And with that, I'll pass things over to Jacob. Over to you, Jacob.
Thank you, Rachel. So today I'm going to go through the basics of utilizing Linux and Bash script. And for this course, I'm going to be utilizing our Sockeye HPC system, though this is generally applicable to any system running Linux and the basic Bash command. Just a quick note before we get started, we do have one more upcoming training session, and that is on Tuesday, April 14th, with our introduction to cloud computing. And this will be a basic overview of cloud resources and some of the various processes that can be done to gain access to them. If you're interested in registering, please click on the link in the slide here, and I'll give just a moment for our new attendee. Okay, so just a bit of an overview of what we'll be covering today. To start off, I will give an example of how you would connect to a Linux system remotely using SSH and some basic terminal commands. Following that, we'll look at how to interact with files and make edits to text files. Then we'll look a bit more at Bash's base system with how to set environment variables and utilize them in scripts, as well as doing file search and filtering. Finally, we'll wrap things up by discussing the Bash feature of piping redirection, and we'll have a very simple demonstration of making a Bash script. So to start things off, we would like to connect to a system. So in this case, we're going to, if we're utilizing Windows, Windows does come with a basic SSH client. Through the command prompt, you can do command prompt your username at sockeye.arc.ubc.ca, and that will connect you into our Sockeye system if you're registered with it. Another program that is very commonly used with Windows users to generate a shell session is the MOBA Xterm system. And with this, you can go through the menus and do session SSH and then set the remote host to sockeye.arc.ubc.ca and then put in your username afterwards. If you're utilizing a local Linux system or a Mac OS system, your built-in terminal with the system already comes with SSH and has many of the basic features that we'll be going over today on the Bash command line, as the terminal language is generally based on Bash. So once you are connected to a system, whether it be your local system, a terminal, or to remote systems such as Sockeye, you'll be presented with a basic command prompt. And this will display your username and an @ symbol, and then the host name of the system that you're connected to. After that, there is a tilde character by default, and then the $ and underscore for where you will be typing commands afterwards. To start things off, the tilde sign is a special character that means your home directory. So wherever you log in by default to a system, that will be your home directory. It is where generally you have access to read and write your own files, place scripts there, and do basic system. If you navigate to another directory, that tilde in the command prompt will change to list the name of the directory that you're currently in. Another important feature of the bash command line is the use of wildcards. So in bash, the asterisk character is a special character that is replaceable with by bash with any matching patterns. So if I was to type something and put a asterisk in it, it would attempt to complete with any files or knowledge that it has to try to fill in that star. So say I wanted to look for every file that ended in .txt, I could do star.txt, and the command would operate on every file that matched that in the correct directory. A few other common arguments and ways to find help about commands is by using the -h flag in a command itself, or typing man for manual, and then the command that you're looking at. Not every command has a full manual, and not every command uses help, but it's very common among most of them to utilize one or the other. A few more things to go over is if you're in the middle of running a command and it's either stalled out or you want to cancel it, say you accidentally started removing a very large directory of files and you didn't intend to, you can hit Control-C. It will interrupt whatever your current command is that's holding the shell, but it will not revert them. So if you went and started deleting files, it will stop deleting more, but you won't be able to roll it back to recover the ones that were deleted. It's also useful if you start something, say a program, and it is taking quite a long time. Maybe there's error with it or something. Control-C will cancel out that current operation and bring you back to the shell. If you'd like to see some of the commands that you previously worked with, you can use either the up arrow key in a bash shell, and that will let you cycle backwards through previous commands. Or you can use the command history, and that will give you a text display of the last up to 1,000 commands that you typed into the shell. Finally, if you want to close your session, you can simply type exit, and that will close out. For an example here, I'm just going to switch over and show off a few of these features in the shell on our Sakai system. So here you can see we were logged into our current system. You can see I've got my username, the login node that we're on, and the tilde symbol noting that I'm in my home directory. So if I wanted to, I could do some commands I'll go over in a little bit later, but just as an example, say I wanted to list every file that ends in a txt, I can do this, and it will find everything that has a .txt at the end. And that is what it means by wildcard replacement. Similarly, if I want to repeat the last command, I could simply hit the up arrow and it'll bring back that command. Or I could type history. We see some of the various commands I've done in the past. And say I wanted more information on the ls command, I could type man ls, and it would give me a scrollable page that would give me more details about what I can do with the ls command.
What does history mean?
So history is a command that allows you to view any previous commands that you typed in and entered in the command. So in that case, you could see at the end, it said ls.star.txt because I had just typed that previously. So it's a way to view what you've done previously in the event you need to either remember, look it up, or reutilize it.
Okay, got it.
Okay, so that jump back to the start. Okay, so I did just show off a little bit of ls, and in this case, I did it to simply list a single file. There are a number of arguments that can be utilized to get more information out of that list. Really common ones are either the -l command, which is the long listing that will give you more information, such as the file permissions and file size and so on. -t will organize them or all the files in order of what is most recent at the top. So the top of the list will be the files that were modified most recently. -r reverses that list. So in some cases, if you'd like to look at the most recent file that was modified in a directory, and there's quite a few files, you could do ls -t -r, and it would put the file that is most recently changed at the bottom of the list and makes it easy for you to look at immediately. Another very important command is the cd command. This is a command that allows you to move where you're currently situated in the file system. So as I mentioned previously, you start in your home directory, but if you have other directories or other paths within a system that you'd like to move to, you can use the cd command to move to it either by giving a path of a directory that's in your current directory, or you can give it a full path starting with a / and the entire path of the directory that you wish to move to. If you wish to move up a directory, so say you went into a directory within your home directory and you wish to move back up, you can move up in a path to the parent directory by doing cd space dot or period. And that command will take you up one directory from where you currently are. If you'd like to see what the full path is for the directory that you're currently in, you can type pwd as a command, and this will print out the list of where you currently are in the system. Similarly, if I would like to make a new directory, so say I want to make somewhere inside of my home directory for a new spot, I can do mkdir as the command, and then a space and the name that I would like to call that directory. That'll create a new directory with the default permissions and set it up wherever you currently are situated in the operating system. Similarly, if you'd like to copy a file or copy a directory, the cp command will let you specify a source and a destination, and that will copy the current file to that destination. Or in the event that you'd like to copy the whole directory, you do cp space -r for a source directory and a destination. I will switch back over here and do a quick demonstration of that. So as we saw before, I use the ls. Now, if I do ls minus L, that'll list everything that's in my current directory with a lot more detail. And you can see I have a lot of files in here, and they're all sorted by alphabetically first. But if I wanted to do, say I wanted the most recently modified file at the bottom, I can do ls minus L, T, and R. And that'll point me down here to the one that I modified today. So in this case, if I want to change to a directory, and bash examples is a directory, I can do cd bash examples, and now we can see instead of being in my home directory, I'm within bash examples directory. I type pwd, you can see it is moved from just my home into that bash examples directory. If I'd like to make a new directory here, I can do mkdir and if I do ls, you can see it's made this example directory. If I'd like to copy a file, I do copy example.txt. We'll put it in example dir, and we'll just call this just one.txt. That's what we'll call it for the destination. So do ls example dir, we can see it has that one.txt. So similarly, now that we've done kind of just the basics of moving around in files, I'll go over some basic commands that we can use to do file transfers and working with archives. So say I'm working on my local system and I have a file that I'd like to upload. There is a command called scp, or SS, which stands for SSH copy, and that lets you send a file from your local machine to a remote system and make a copy there. So for the command, you do scp, your local file, and then you do a space, and then similarly to how you use SSH, you give your username, the remote server, and then at the end you do a colon followed by a path where you'd like to place that file. And when you submit this command, it will attempt to initiate an SSH session. So in the case of Sockeye, it will prompt you to do two-factor authentication and log in with your password. This is a good way to, you can also do this in reverse. So say you wanted to copy a file from a remote system back to your local. Instead of putting your local file first, you'd put the remote system first and then where you'd like to copy it back locally. Effectively, the first argument is your source, or where you'd like to copy from, and the second argument is where you'd like to copy it to. Now, as far as the working with compressed files, by default, Bash and Linux systems will support basic tar, which is an archival system. This is an uncompressed archive, so the full size of all the files are preserved in the archive itself. But it does bundle all the files into a single file. To create an archive, you can do tar cf, which is create, and then f is to give a file name for the output. You give the output name. So in this case, we'll just call it new archive.tar, and then you give it the source of the data that you'd like to copy in. So in this case, with some file directory. Now, if we'd like to also apply compression to it, we can use the Z flag. So it would be tar czf. And this flag applies basic zip compression. So we'd have an output file, and we're going to call it the new archive.tar.gz. And that's just a common convention to denote that this file is compressed with zip. And then similarly, again, we'd have a file directory that we'd like to compress. Now, if we would like to expand an archive, we do the same thing in reverse. So we do tar and then xf. We'll take an existing archive and expand it out to whatever directory or directories are within that archive. Similarly, if we have a zip archive, we need to add a Z to let tar know that it needs to first unzip the archive before expanding it. Now, I've gone over a number of things so far. I'll pause here for a moment to see if there's any questions from our attendees and if there's anything you'd like me to go over in more detail. All right, moving on. So now we kind of have the basics around manipulating files within the bash system. So if we'd like to write some text files, we do only have a command line, which makes it a little bit difficult for writing text and trying to insert it into a file. So to help us with this, we have a basic text editor that can be done over command line, and that command is called nano. And this is a simple piece of software that is commonly found on most Linux systems. Some Linux systems, you may have to install it first if it's very basic, but generally, if you're connecting to Socket or other systems remotely, they'll very commonly have nano installed. And to start the software, you can simply type nano and hit enter, and that'll give us the option to bring up this text editor, and you can either start typing text in it and basically create a file that way and write it out, or we can read in a file to open it and make modifications. As a quick example, bring that up here. I type nano. We can see we have a similar screen to the one that I had. I can type text in here. So and I'm simply just using my arrow keys, enter, and typing the text here to generate that file. So it is quite easy to navigate through the text. And at the bottom of the line here, or at the bottom of the screen, we have a couple of commands. Each of these correspond to using the control key and the batching key afterwards. So if I write out is the way that we would save a file. So if I do control O, it'll ask me what I would like to name the file. In this case, I will do course.txt. And it tells me that it wrote 3 lines and it's available. I can do other things such as cut and paste. And in that case, I would move up here and say cut, paste, and it will do it line by line. Now, when I'm ready to finish, I can do Control X, and it'll ask me if to save modified buffer, meaning I've made edits to this file since I last saved. If I would like to, I simply hit Y for yes, and it says write to the name that I gave it earlier, supports.txt, and it'll close out. If I do nano again, I do Control R to read a file. I do supports.txt, and we're back to working on our file. Now, are there any questions around utilizing the nano file system, or am I good to move on?
I think you're good to keep going. Thank you.
Okay. Yep. Okay. A little bit more about the Bash command line system. So built into most Linux systems are a number of environment variables that commands and software will use to identify things. A few basic ones that are set up by the system itself when you log in is PWD, which is a environment variable that always displays wherever your current working directory is. So similarly to when you type the PWD command, this environment variable will always know wherever you're at in the file system. The path environment variable is a list of directories that the system will look in to try to find executables to run. So in my case, when I was running the nano command, nano is in the path by default set up in one of the system directories. You can add additional file directories to this path, and those will then work as basically being able to call the executable there without having to type the full path of the executable. Another one that's really useful for scripting is your username. It will always be displayed under the user environment variable. And you can print any of these out to the screen itself if you just like to view them by using the echo command. So if you do echo $user, it'll print your username. Same with PWD or path. Now, in some cases, we'd like to set our own environment variables. So say I'm building a script and I want to set some values in it. But like to do that, I can use the command export var name and then whatever value I'd like. It can be a numeric value, a text value, a path. Whatever you type out will be stored. And calling export means that it exists beyond the single instance of the command on the system. So it'll last until you exit the shell itself. Again, it's very useful for working with scripts or various bits of software if you'd like to set environment variables that are needed for their execution. Similarly, another thing on the Bash system that's very useful is if you'd like to find names of files within the current structure. So say I'm looking in a directory or a large tree of directories, and I want to find a specific string for files. So say maybe I have a lot of data files and I'm looking for an output data file that ends with, say, a date that was run. What I can do is I can use the find command. Dot means to start searching in the current directory that I'm in, and then dash name and search string will search all the file names within a path as far as it can search. for something that contains that search string between the two asterisks. As I mentioned earlier, the stars are used as wildcards, so they will fill in any extension to that file or that search string as needed. So if you're looking for only an exact file and you know the exact name, you can use just that without the star. If you only know a partial name, you can put the stars or asterisks around it, and it will use that as a wildcard for the search. A few other ways that you can use search to find things is you could search by a username. So a user that figure out who, which files are owned by a specific user. You can do find dot and then use the dash user and a username string, and that will find every file within the current set of directories that is owned by that user. Same way if you would like to try to find files that have specific permissions. In this case, we were looking for permissions with the -G plus X, and this stands for, we're going to search for permissions that have the group permission set to executable. So this will find anybody who is executable by a group. And another command that Bash provides that's useful for working with files is, say we want to, rather than just searching for the name of a file, we know that, we have a log, say, from a command that we're running. And we'd like to look within a very large file that has a lot of logs, or maybe something that says error. So we can see potentially, why something failed. We can use the grep command and do grep the string that we're searching for and a file name, and it will search a text file to try to find that matching string somewhere and display the line that it found that text in. Give a brief example of that here. So let's say I want to search for every file that has the word bash in it. So I've made a few of them within this directory. If I do find bash name and then do star bash star, we can see it's found the two that are in my current directory, as well as these two scripts that were created up above in another directory. I'd like to search for, say, instead, we're going to search within a file. Let's look for bash and this course.txt that I typed bash in a few minutes ago. You can see it searches and then we'll highlight that word bash in the line that it was on. Now, if there's multiple lines that match, it will display each line that matches with the highlighting on it. So now we're going to come to one of our last topics for the Bash course, which is about piping redirection. So Bash supports something called piping, which allows you to effectively join the output from one command into the input for another command. So two of the commands that we've used previously was the ls command to print a list of all the files. And we use the grep command to search a text file for a string of text. If we use the pipe command, we can actually connect these two together so that the list of all the files that is output from ls is actually treated as the input file for the grep command. So I can effectively list all my files and then search it using grep to find a specific name for a file or a specific permissions or so on. This can be very powerful for a lot of commands, especially if you have any sort of input output that is printed to the screen and needs to be brought into another command to do, say, text processing or as an input variable. Types are very powerful in doing this, and you just need to make sure that when the output is being handed off from one program to the next, it's in the format that's expected. Similarly, with redirecting output, rather than sending it to a command, if we want to write it or read it from a file, we can actually utilize the left and right carets, or the less than and greater than symbol. And if we use the greater than symbol, that is a way that we can take the output of a command that would normally go to the screen and direct it to be written into a file. This is very useful if you have, say, some simulation software that prints a lot of logs to the screen while it's running, and you'd like to capture that in a specific file. So in this case, we're just using the ls command, but any sort of command you can use the greater than symbol and point it to a file and basically write out the text that it prints out. Similarly, if we want to take a file and have it as input for a function, we can do that with the less than symbol, and that will basically treat whatever file that you have that you're inputting as the input for the command itself. This is really useful if you need to pass in, say, like a non-text file. In this case, we're just using a text file for grep, which you can already handle. But say you want to pass in something that's doing data processing, and you need to specify an input file. This is a very common way to do that and allows you to import that file. And just to wrap everything up, we'll go over a bit about bash scripting. So all of the commands that I've presented so far are just kind of basic parts of the Linux system. Bash itself is very powerful and lets you have the ability to write a script that contains multiple commands and effectively bundle it as a single command to run. So all of these commands we can write into effectively a text script, and much like many languages, it provides comments. So if we want to provide descriptions or notes within the script itself as to what it's doing, we can start it with the hashtag symbol. At the top of the script, it needs to contain something called the shebang, and that is a hashtag, exclamation point, and then what the system is going to run the script with. In this case, for all of our scripts, we're just going to use /bin bash, which tells it that this is a bash script. Once we are finished writing our script, we'll save the file, and then we need to make sure that the file is marked as executable by the system so that you can run it as a command. And we can use that with the changing of permissions. And the command to change a permission in the file is the chmod. So since we just want to add execute for ourselves, we do chmod u + x and then the name of the script itself. Finally, if we want to just execute a script that's local, we can do that with / and myscript.sh, where that would be the name of the script that you've made execute. So I will go through a brief example. This is a simple example that I have our students work through when we do our summer school course during the summer. And it basically takes all of the details that we've utilized over this, or we've gone over for this course, and you create your own script for it and run it to you. Oh, whoops, this is screen. So if I look at that script, we can see here it does a number of things. So we start off at the top with the shebang, which tells us that this is the bash script. And we set this environment variable script version. And we say we're going to call this 1.0. I then list all the contents of a directory and redirect that info from ls into a new file that we create. And we're just going to call that directory contents. Then we're going to copy all of the contents recursively of that directory from bash example into our home. We'll do a tar, which will compress with the zip and create a compressed directory that contains both the directory contents itself as well as that directory that we just copied. Finally, I'll run a quick check over that directory we just copied and see if we can find any files that have the user with an execute permission. Once we've done all that, we'll then print out to the screen listing our script version that we created up above and just the words done. So this is kind of what I can go over with the basics of bash in about an hour. So we do have a bit of time. I'd like to answer any questions before I finish up and make the survey of it. So for our attendees, do any of you have any questions or anything that you'd like me to go back and explain in more detail?
I'm good on my side.
Okay. All right, let me just finish up. I will put on the slide here with our feedback survey and hand it off to Rachel to wrap things up.
Thank you, everyone, for joining us today. We really appreciate your time. If you can, please take a moment to complete the post-session survey. You can just use the link on your screen and then click into it. Your feedback, it's going to help us to improve future sessions. Thank you so much again, and have a great rest of your day. We hope to see you in future sessions.
Thank you very much.